Unit 1 SLT30 is triangle congruence. I'm just going to go over a little bit more about triangles and congruency. Some quick vocabulary review. The midpoint. Oops. The midpoint is a point directly between the two endpoints of a segment, and it divides the segment into two equal parts, or two congruent parts. So say you have a line segment from here to here, and this is the midpoint. That means that this side is congruent to this side. And then remember the word perpendicular bisector. The perpendicular bisector of a segment is a line that intersects a segment at its midpoint and meets the segment at a right angle. So that's if we have a line and its perpendicular bisector. That means that it makes a right angle and it makes a midpoint, which means this side and this side are congruent or equal to each other. Don't forget about angle bisectors. Remember, if you have an angle and something bisects it, that means that those two angles are going to be the same. It can be 30 and 30, the same degrees, same measurement. And then lastly, the reflexive property. States that an object or quantity is equal to itself. So for example, if you have two triangles that share the same line in the middle, that line is congruent to itself. So say that line was BD, we would say BD is congruent to BD because of the reflexive property. Okay, so read along with me. For each pair of triangles, tell whether the given information is enough to show that the triangles are congruent. If the triangles are congruent, state the criterion that you used to determine the congruence and write a congruency statement. Note that the figures are not necessarily drawn to scale, so even if they look congruent, they might not be congruent. Now, when we're reading these givens, we want to read them and then mark it on our figure. So BC is the perpendicular bisector of AD. So if we look at BC, okay, it's perpendicular bisector of AD. That means it makes a right angle and it bisects AD, so this side is congruent to this side. AC is congruent to DC. Now it's asking us if is triangle ABC congruent to triangle ADC? Well, let's look and make sure there's nothing else that we can say about this. So if you remember what we just talked about, we talked about a property that if they share the same line, that means it's congruent to itself, the reflexive property. So we can mark this and say that this line is congruent to itself. So I'm going to put 2 marks since I already have congruent lines with 1 tick mark. And now I'm looking and I see that I can say this is congruent because a side, angle, side. So my reason for them being congruent is side, angle, side. And the congruency statement is triangle ABC is congruent to triangle ADC. Now the next one, I'm not given anything, but if I look at the picture, I know because of the reflexive property that the middle line is also congruent to itself. it looks like they show us that angle C is congruent to angle A, and line BC is congruent to line DA. So let's see here. We have a side, an angle, and a side. Side, angle, side. And we have the same thing on the other triangle. So these are congruent because of side, angle, side. And the congruency statement here would be triangle ABC is congruent to triangle CDA. Now if you look at the next one, we also have the reflexive property here. So that line CA is congruent to itself. And if we look at BC and DC, those aren't corresponding lines on each triangle. So if we look at this one, this triangle, we have side, angle, side. And on this triangle, we have angle, side, side. And that is not a reason. So that one is not congruent. In number 4, it gives us that G is the midpoint of EH. So if G is the midpoint of the line EH, midpoint bisects something. It cuts something into 2 equal parts. So this segment is congruent to this segment. EG is congruent to HG. And we also know about vertical angles. I don't know if you guys remember this, but vertical angles are angles that are directly across from each other. So these vertical angles here you can see right here and right here, they are congruent to each other. Vertical angles are always congruent. Whenever you have 2 intersecting lines, the angles across from each other, either there or here, are congruent to each other. So here and here, and here and here. So if we look back at our figure, we have a side, we have an angle, a side, and an angle. Angle, side, angle. So the reason here is angle, side, angle. Triangle FEG is congruent to triangle IHG. And then the last one, it says JL is perpendicular to KM. JL is perpendicular to KM, so it means it makes right angles. And JL bisects the angle KLM. So since JL bisects that angle, I think it's supposed to be KJM. It's supposed to be KJM. So if it bisects KJM, then those 2 angles are congruent as well. And we even have our reflexive property here. So with the reflexive property, the line that they share, it's equal to itself. So now if we look at it, we have angle, side, angle. And over here we have angle, side, angle. So the reason they're congruent is because of the angle, side, angle theorem. And we would say triangle KLJ is congruent to triangle MLJ. Now you can complete the Go formative for SLT30 and then check in with me when you're done with that.